Travis. How are you doing, my friend? Yeah, it's another wonderful day in pure paradise. Yeah, woohoo. Yeah. And who do we have here? Ooh, look at it's a mouse. Hey, you're a cute little mouse. Whoa, man, look at those big ears. My goodness, you look like Despero. That's right. I knight you, Despero. Yes, it's another math video. And, ooh, you hiding something there, buddy? You look like you're hiding something. Well, look at here. Trying to hide my math problem? All right. Yeah, I know. What's that? Oh, no, I'm sorry. I really don't know about any. I don't have any cheese. Really? Yeah, I'm sorry, but that's all you guys live for, huh? It'd be kind of cool. Hey, you know what? I don't know. This is kind of a thought, but have you ever considered, like a little goatee? I mean, I love your whiskers. They're happening, but what about like a little goatee? What do you think, huh? Yeah. No, there you go. Yeah, now you look more established. Maybe some highlights in your ears. Just kidding. Yes, Mr. Ward, it's time to get more serious with math. Yes, that's right. Okay, let's get on with it, shall we? We have a learning target. Our learning target is connect division by a unit fraction to division by 1/10 and 1/100th. Cool. We're connecting division with like the idea of a fraction, but a unit fraction, which we already learned, at least we covered that material. A unit fraction just being that 1 over a unit fraction, like 5 or 6 or 7. And we're going to do that with the 1/10 and 1/100th. Cool! Sounds like fun! Yes, it does, and I'm really excited about today's lesson because I'm always excited about learning how numbers interact with each other and, the patterns and the different things that we can see. It's just very, very fun. Okay, here we go. Hey, our friend Mousy is back. Ooh, you lost your goatee. Didn't like it, eh? Oh, well. It says 7 ones divided by 1/10. Interesting. Now, 7 ones divided by 1/10, I could just write that as a fraction. I'm going to go ahead and say, well, 7 ones divided by 1/10. And I'm wondering, what question does this division expression ask us? I would say, well, here we have the 7, so 7 is really 1/10 of what number? And that's a way that we could actually phrase that. Okay, because we're trying to figure out how many tenths there are in 7. So that reversing is just like 7 is 1/10 of what number? So let me write this statement as well. So here, let's just start with just 1 whole. Okay, how many tenths are in 1 whole? There are 10 tenths in 1 whole. So let's continue on with that thought. Right, so let's look at this one then. There are blank tenths in 7 wholes. Well, if there are 10 tenths in 1 whole, then we're looking at how many are in 7 wholes. And I think I heard somebody say 70. Woohoo, you guys are so smart. Yes. Now, the question is kind of how do we know that there's 70 tenths in 7 wholes? Well, maybe you've been thinking, well, if there's 10 tenths in 1 whole, so 20 tenths in 2 wholes, 30 tenths in 3 wholes, and the pattern, we end up with 70 tenths, right, in 7 wholes. And 7 is 7 times greater than 1. So 70 tenths then is going to be 7 times more than 10 tenths. Okay, are you following along here? So 7 times 10 is 70. So there are 70 tenths in 7. And that's a very, very important concept to understand. Obviously, we're talking about the power of 10. Now let's think of this too in another way. See, 7 is 1/10 of what number? And that was that question that I put up above here, or not a question, but was a statement. 7 is 1/10 of what number? And now putting that as a question, how would we solve that? Now maybe you're thinking that the answer would be 70 because of what we just talked about. Yeah, it would be 70 because, I can think of it as like a tape diagram with 10 parts. If I had middle here, I need to have 5 on this side, 2, 3, 4, 5. So it's like I have a tape diagram with 10 parts. And one part would be 7. So 7 times 10 is going to equal 70. See, I can think of place value when I look at this. Each one really being 10 times as great. It's clear then it's 10 times as much. 70 is 10 times greater than 7. Okay? Yes? Okay, let's go on. Okay, now we have another problem. So now we have 7, and 4/10 looks like divided by 1/10. Okay, well, let's rewrite this as a fraction for the divisor. So if I were to write this, I could write this as 7.4 divided by 1/10. Think about the problem that we just solved. What do you notice about this particular one, huh? Similar? Different? Yeah, you know what? One thing I noticed is we were dealing with the number 7. So there's still 7 holes. You can see there's still 7 holes, but now there are also 4/10. That's right. And the hole in this problem is just 4/10 more than problem 1. So instead of having the 70/10 that we had, in this problem we have 74/10. But we can ask ourselves in this situation here, that 7 and 4/10 is 1/10 of what number? Because we have the same divisor of 1/10. So let's write that. 7 and 4/10. My 1 here, this is a 1, looks kind of sloppy. There we go. Okay, so 7 and 4/10 is 1/10 of what number? Well, we already know part of this problem. If you recall, our problem when it said there were blank tenths in 7 holes. We said how many tenths are in 7 holes? Yeah, we said 70. Okay, so there's 70 tenths in 7 holes because there's 10 tenths in 1 hole. So there are blank tenths, when you think about it, in 4/10. And that's pretty easy, right? There's 4. So how many tenths are in 4/10? 4. Easy. So we're just adding our 4/10. So we end up with 74. So the question being 7 and 4/10 is 1/10 of what number? 74. Is 74 10 times greater than 7 and 4/10? It is 10 times greater. So that would make sense that 7 and 4/10 then is 1/10 of the number 74. And again, how many tenths are in 74? 74/10. I'm sure I don't have any cheese. This guy, him and his cheese. Okay, anyway, so now we have 6. 6 divided, okay, by 1/10. Okay, sorry about that, Mousy. All right, I'm sorry, Despero. Now, how many tenths are in 6? Yeah, it's 10 tenths in 1 hole, therefore, right, 6 times 10. So we would end up with, yeah, there's 60 tenths. And so then 6 here, 6 is 1/10 of what number? Yeah, were you thinking? 60. You're right. Man, you guys are on this already, huh? It is 60 because we're looking at the 1/10 and almost might even seem like a little inverse operation here, right? Times 10, 1/10, right? Being opposites. What if we'd put, instead of the 6, 6.2? Same question. How many tenths in 6 and 2/10? Are we following the same pattern? Right. 62 tenths. So then 6.2, right, is 1/10 of what number? And you guys already know it, right? It's 62 because you saw that from above. Because 62 is 10 times greater than 6 and 2/10. Therefore, 6 and 2/10 would be 1/10 of 62. Or how we phrased it, 6 and 2/10 is 1/10 of what number? Which was 62. Are you liking this? Now, I hope that you're kind of catching this idea, but let's look at another one here. Here we have 9 divided by 1/10. So let's go ahead and do what we've been doing. Let's go ahead and take our 9 then. It's really 9 divided by 1/10. As you can see, we've just put that in fraction form. And, right, we can ask that same question again. Then 9 is 1/10. 9 is 1/10 of what number? And we looked at that before and we said, okay, well, how many tenths are there in 1 hole? Remember? And we said there are 10 tenths in 1 hole. So then how many tenths would there be in 7 holes? Or would that not just be 9 times 10, which equals 90? If I wanted to do my tape diagram, again, I could show this by dividing it into tenths. 9 is 1/10 of that number, which is 90. Isn't this fun? Oh my goodness, this is so easy. Mr. Wara, easy peasy. Lemon squeezy. Yes, okay. So again, following that same process, we are looking at this problem, and Now we have 9 and 8 tenths divided by 1/10. Let me rewrite that problem. Okay, so we can make that connection with a fraction and the decimal. So again, the question that we would ask is that 9 and 8 tenths is 1/10 of what number? And we looked at this before, same pattern. We know that there's 10 tenths in one whole. Now we have 9. That means we have 9 90 tenths, and we also have 8 tenths. So we actually have 98. Because now again, if we were to divide that 98 into 10 equal pieces, we'd find that 9.8 is 1/10 of 98. Right? So a lot of these are following a similar pattern. Okay, let's look at another problem. Here we have 7 divided by 100th. So let's rewrite this problem like we have been using that unit fraction. And we have that unit fraction of 1 over 100, as that's the decimal fraction connection between those two. We can think of this really as how many hundredths are in 7. I'm wondering if our thinking needs to change to solve this based on the problems that we were doing earlier. And I'm not thinking it's going to, because the question is really the same question. I mean, how many smaller units are in one whole? That's what we really have been asking. The units we are counting are definitely different, but that doesn't really change how we find the answer. We're going to use the same process, the same procedure. So I wonder, will our quotient then, is it going to be greater or less than our last problem that we did? What do you think? I'm kind of thinking that our quotient's going to be a little bit greater, because what we're counting units now that are much smaller, so there will be more of them in the wholes because we have that denominator of 100. It's the same basic idea of what we're doing, but since our divisor has gotten extremely small, the quotient should be larger than it was before. Okay, so before we think about how many hundreds are in 7 wholes, let's find out how many hundreds are in one whole. And I'm sure a lot of you are saying, I know the answer. Pick me, pick me. Yes, I pick you. Yes, there's 100, right? 100 hundredths in one whole. And I can't help but always think that this reminds me of the pennies in our money system. Okay, everything's based on a dollar. If you have 100 pennies, then you have 100 hundredths in that $1. You have 100 pennies in a dollar, and it fits that. Kind of nice. If there's 100 hundredths then in one whole, then we could just follow up by saying how many hundreds would there be in 7 wholes? Right, it would be 700, right? If you have 7 wholes, so we have 700 hundredths. So let's look at this problem then. What is the whole in the division expression? Yeah, isn't it that 7 and 4 tenths? I'm thinking how I would like to solve this problem. Well, again, we're following that same pattern with that 7 wholes. Here, this problem is just 4 more tenths than the one that we just solved. So we definitely need to figure out how many hundreds are in 4 tenths. Okay, well, we know there's 700 hundreds, right, in 7 wholes. Okay, in 7 wholes, so we just need to deal with the 4 tenths. So this is just going to be 4 more tenths than that problem that we had. There are 10 hundredths in 1/10. Okay, let me write that down. There are 10 hundredths is equal to 1/10. And again, am I thinking money? I am. There's 10 pennies in 1 dime. That's right, because a dime is 1/10 of a dollar. So we have 10 pennies in 1 dime, so 10 hundredths in 1/10 follows that pattern. Well, that means then that there's going to be 40 hundredths because we have 4 tenths. And 10 times those 4 tenths that we have up above is going to equal 40 hundredths. So we're going to end up with 740. Hey, buddy, look what we have here. I see there's some cheese. Hey, you want to come and get it? Come and get it. Oh, yeah. Give me cheese. I want cheese. I want cheese. I want cheese. I want cheese. Where'd he go? Oh, my goodness. He like disappeared. Oh, you know what I think he did? I think he dove inside the cheese and he's eating from the inside out. Oh, my goodness. Mice. They're just, Despero. Anyway, a cool guy. It was nice having him along. Guess he's moving on. Well, we have another problem here. Now we have 7 and 49 hundredths. So let's go ahead and solve this problem. Okay, I wanted to go ahead and put all the information down that I was using to solve this problem. But looking at that, I can see right away that there's definitely 9 hundredths, right, in that problem. And I can also see that there's 4 tenths although I wrote down that 4/10 was equal to 40 hundredths. I also see that there's 7 holes, and 7 holes we just solved earlier with 700 hundredths. So our final result here then is going to be 749. So let's go ahead and try some more. How many hundredths are there in 6? Yeah, pretty simple. Now we know 600. There are 600 hundredths in 6 holes. How about 6.2? Starting to see that pattern? Yeah, we have 600. We said that there were 10 hundredths in every tenth, so wouldn't we have 620? Now how about 6 and 2 hundredths? Right, we still have the 600, but we're adding on 2 of the hundredths that were already there, giving us 602. Nice. How about 12 and 6/10? So here we have 1200, 1200 plus there are 10 hundredths in 1/10, so we would have 60 hundredths, giving us 1260 hundredths. Okay, and the patterns continue. So you notice the pattern here that we're noticing is we find the number of hundredths in each of these quantities, right? And so the digits stay the same, but they are in a larger place value in the quotient. So I'm beginning to even notice that when we divide by 100th, each digit shifts 2 places to the left. And it's just like multiplying by 100. And I made that statement in the video that finding 1/10 of a number, right, when we're trying to do that, again, it's inverse operation. So saying that this number is 1/10 of, right, it was also multiplying that number to get us back. So this helps us think of our division expression differently. See, when we divide by 100th, we can think, you know what, this number is 100th of what whole? See, or maybe what number is this 100th of? Means the same thing. So let's just do one more here. So let me put this question. What number is 7 100ths of? So that same expression. What number is 7 100ths of? Yeah, 700. It's like thinking 7 times 100 because 7 is one of 100 parts. It's place value again, but this time the digits shifted 2 places to the right. As we look at 7, you can say that the digits shifted 2 places to the right. That's one way you can look at it, or that the decimal moved 2 places to the left. That would be our 7, right? And we were dividing that by 100th. Because we were dividing by that 100th, that's the same as multiplying, right, by 100. And so in this case, the decimal moved 2 places to the right, or if you better think of the digit moved, that the digit shifted 2 places to the right. So let's go back and think about our learning target. So did we connect division by a unit fraction to division by 1/10 and 100th? We did. We connected division by a unit fraction to division by the 1/10, which we used, and 100th. All right. Yes, it's done. We did it. Woohoo! Yeah. And complete. I don't think we have any more work here. I think that completes it, and we're ready. Oh no! What is this? You know, this is crazy. Okay, now what's up? Oh, really? You found a cheese stockpile? Okay. In the video? Really? Sure. Mr. Warren keeps these little factories of cheese, in the math video. Okay, this is just getting really crazy. Yeah, okay, I would think so. Well, at least you were kind and you shared your cheese with your friends. That's kind of nice. Okay, hey, you have a good heart there, Despero. Now, you sure you don't want that goatee? It's not too late. I could, oh, no? Oh, I see, huh? Oh, you like that one because it's pink. Okay, well, let me go ahead and do this for you. Yeah, pink whiskers. Oh my goodness, that's really happening. A little bit highlight in the ear maybe. There you go. Maybe on your little bit of tummy there, running down. Oh my goodness. Yeah, cool. And now I'm not going to draw a tattoo. Oh my goodness, got a tattoo. Okay, you guys. Hey, it's been a lot of fun. Now, my friends, live long and prosper.